For MAT300 group assignment, our topic is ordinary differential equation. We are from RCS 1436A. With me, we have our fellow gentleman, MOHMAD RIFHAN bin ROSLAN, with the matrix number 2020472788. Me, myself, NURIN SYAZWANIE BINTI MOHMAD JAFRI 2019247044, and beautiful young lady REZAAZRINAZAWATI Stephen 2020610748. Assalamualaikum. Nurin will explain the introduction part. So, application of ordinary differential equation. What type of application that this have? Application of ordinary differential equation. There are two types of application. First one, we have application of separable equation. Second, we have application of first order linear equation. Application of separable equation. 1. Growth and decay. 2. Radioactive decay. And 3. Newton's law of cooling or warming. Application of first order linear differential equation consists of two types, which is mixture problem and electricity current. While electricity current consists of two types of circuit, which is RL circuit and RC circuit. In this topic, there are a few things our group decided to focus on: Newton's law of cooling or warming. What is Newton's law of cooling or warming? Newton's law of cooling or warming is a rate of change of body temperature proportional to difference between the body temperature and the surrounding temperature. The model is d capital T over d small t equal to small k T minus Tm, which I will ask the explanation of that model in the next page. So, objective of Newton's law of cooling or warming is used to predict how long it takes for a hot object to cool down at a constant temperature. It also helps to indicate the dead time given by the probable body temperature at the time and the current body temperature. The source is from protostock.com/thermal properties of matter. That's all from me. We will proceed to Reza.
Okay, at first, we need to explain about the general equation. The equation is solved by separate the variable and integrate both equation. So at first, we need to separate any variable, and for the example is t and k, and we need to integrate both sides, and we're gonna get an equation. Then the general equation of the temperature of the body at any time is we're gonna use T equal to AEKT plus Tm. And at the last, find the specific solution with value of A and K by apply a condition given, which is the condition given is T0 equal to T0 and T1 equal to T1. Okay, next we move to the question. A hot pipe that was cooked at a constant temperature of 325 degrees F is taken directly from an oven and placed a loop where the temperature is 85 degrees F. After 5 minutes, the temperature of the pipe reduced to 250 degrees F. Determine the temperature of the pipe after 20 minutes. And at last, the time required for the pipe to reach 150 degrees F.
Assalamualaikum, my name is REZAAZRINAZAWATI binti Stephen, and I will explain how to get answers to questions step by step. Before we can solve both of the question, first thing we must find the general solution and the equation that describing the temperature of the pipe. From the question, we get the first information, which is T expected to 0 is equal to 325. Second information we had is the temperature of the surrounding object Tm is equal to 85. And lastly, we have the temperature of the pipe at time 5 is equal to 250. After that, we can substitute the information given to the model expressed as dt over dt equal to k bracket T minus Tm, where the Tm, which is temperature of surrounding object, is 85, subject to T expected to 0 equal to 325 and T expected to 5 equal to 250. Then, to get the general solution, we have to solve the differential equation by integrate both sides. Now, we have integration of 1 over T minus 85 dt equal to integration of k dt. Solve the integration, we got ln T minus 85 equal to kt plus e. Then, we add exponent to the both sides so we can cancel out the ln at the left side. After that, we have T minus 85 equal to exponent of kt times exponent of c. Since the operation between the variable of kt and c is an addition, so we can separate it. Then, we change the exponent of c to a constant variable, which is a, and bring the negative 85 to the right side. Finally, we got our general solution, T equal to a exponent kt plus 85. We found the general solution. Next, we have to find the equation by applying the conditions given to find the values of a and k. First, we apply the condition of T expected to 0 is equal to 325. Substitute the value of T is 0 into the equation that we got just now, which is T equal to a exponent of kt plus 85. So, we'll have a exponent k0 plus 85 equal to 325. Solve for the a, we got a equal to 240. Next, we apply the second condition, T expected to 5 equal to 250. Same as before, we substitute the value of T and value of a that we got just now. So, it will be 240 exponent 5k plus 85 equal to 250. We can solve the right side and leave the exponent of 5k at the left side. Then, add natural log on both sides so we can cancel out the exponent on the left side. Then, we will have 5k equal to ln 11 over 16. Finally, solve for k. We got negative 0.07494. Correct to 4 significant digits. We haven't finished yet. We need to substitute back all the value of a and k into the general solution. After all, the equation that describing the temperature of the pipe at time t is 240 exponent of negative 0.07494 t plus 85. Now, we can solve the question 1 and 2. The first question is to determine the temperature of the pipe after 20 minutes. We can write this as T expected to 20. Just substitute the value of T into the final equation and solve. We got the answer is 138.62. Move to the next question. Determine the time required for the pipe to reach 150 Fahrenheit. This can be written as T expected to T is equal to 150, which means we need to solve for the T. After substitute the value, we will have the equation of 240 exponent of negative 0.07494 T plus 85 equal to 150. Leave the exponent at the left side and add natural log on both sides. Cancel out the exponent on the left side. Then we have negative 0.07494 T equal to ln 13 over 43. Solve for the T and got the answer is 17.43.
After 20 minutes, the temperature of pi reduced to 138.62 degrees. For conclusion, the pi needs 17.43 minutes to reach 150 degrees.